a matrix is a way of arranging a set of numbers so that they can be used to do certain tasks. So in this lesson, we're just going to be looking at kind of what a matrix is and how to do some basic things with them. And then as we progress through the second half of chapter 3, we'll start learning about more and more about how they work and how to do different operations with them and what you can do with matrices. But basically it just has a row, some rows and some columns of numbers. Now this has dimensions because there's some number of rows and some number of columns. Remember that columns are vertical, they're up and down. Rows are horizontal, which is left and right. And so we will always, when we're listing the dimensions of a matrix, we will list the number of rows first and the number of columns next. So this one on the screen here, this is a 2 by 3 matrix written as 2x3. If we're going to add matrices together, it's actually quite simple. We just add the corresponding pieces together. So we're going to build a new matrix. It'll have all the exact same dimensions. So this one will also be a 2 by 3 matrix. And we're going to add the top left of each one. So 1 plus 2 is 3. Adding top left plus top left gives you 3. If we then add the top middle plus top middle, 2 plus 2 is 4. That's the new top middle number. And then top right plus top right. Add those together, we get 7. Keep going along in this fashion. And I guess my pen is not working. There we go. So that's a 7. Then on the bottom left, 4 plus 3, also 7. 5 plus 3 is 8. 6 plus 2 is 8. Fairly simple for adding them together. And if you're subtracting, you would do all the exact same thing. Like say if this were a minus here, you would do the same thing, except instead of adding the numbers, you would subtract them. So if that were subtraction, the top left number would be -1. Top middle number would be 0. You just go through, do all the same stuff, but subtract. If we look at something like this, we try to add these together. Well, maybe we could say add the 3 plus the 5 and get 8. But then when we try to add this 5 here, there's nothing there to add it with. So this is actually impossible. We cannot add these two matrices together. So in order to add matrices together, they need to have the same dimensions. There's no way that we can possibly do this matrix addition. So this is not possible. Something like this is subtraction. Actually, I showed you that earlier, so let's just skip over that. A scalar. So we can have a scalar in front of a matrix. Basically what that means is it kind of scales the size of the matrix. So think of like a scale model of an airplane or a train or something. So you can have something that's really the same dimensions, very similar to it, except it's either bigger or smaller. And so when we have a scalar in front of a matrix, it just means we're multiplying by some number that's going to make the matrix either bigger or smaller. So we look at this. Basically what we do for this is essentially just the distributive property. But we've got 4 things to distribute that 3 to. But we just take that matrix and multiply everything in it by 3. So 3 times 4 is 12, 3 times 3 is 9, 3 times 6 is 18, 3 times -7 is -21. And that's it for scalars. Just multiply everything in the matrix by the scalar out front. We can do the same thing for this. You know what? We don't need to do that. I think you guys got it from the last one. But let's do something like this. So this time we've got scalars mixed with addition. So let's first start with the scalars. So let's take this matrix on the left and multiply everything in it by 2. So there's everything in the matrix on the left multiplied by 2. Then we're going to add to that the matrix on the right, but with everything multiplied by -3. So we'll get -9 up here, -12, -27, and then +18. Now that we've taken care of the scalars, all we have to do is add these together. So think of it like the distributive property. If you had 2 times something in parentheses plus -3 times something in parentheses, you would distribute first. Then once you distribute, you can start combining together. All right, so top left of each, -8 and -9, that's going to be -17. Top right of each, combine those, we get -6, so 6 plus -12. Then for the bottom left, we get positive 12 and negative 27, combine those together and we're going to get negative 15. And then 4 plus 18 is 22. So that is our new matrix. And lastly, let's look at something like this. So we've got variables in here, so we want to find the variables. Well, first of all, before we look at the variables, let's actually look at the top left of each spot. So we've got a 1 here, a 2 here, and a 3 here. But remember, we've also got this scalar here that we've got to multiply by that 2. So if we look at this, this should make a true statement here. So if we take negative 1 from the top left of the first matrix, then we do 2 times that 2 there, we get 4, add that. It should equal the top left of the matrix on the right. Well, negative 1 plus 4, that is 3, so this is a true statement. So if we're wanting to find one of the variables, we can set up something like this, but with the variables. Oops. Okay, so looking in the top right spot of each, we've got a 6, we've got this 3x, and that 18. So if we want to find x, what we can do is we can take this 6 from the top right of the left matrix, then plus, make sure to do 2 times that 3x is 6x. That should equal the top right of this matrix here, which is 18. And now we can solve this for x. So we subtract 6 from both sides, we get 6x equals 12. Divide by 6, and x is 2. To find y, we can do exactly the same thing. So we'll take, let's see, y is in the bottom left spot here, so we'll take the bottom left 2 plus 2 times negative 4y, which is negative 8y, equals bottom left spot of this one, which is 26. Solve this equation like normal. So we could maybe, subtract 2 from both sides. That gives 24. And then divide by negative 8, and we get y equals negative